and I work in a technical success team, and I'll be going through some BVD troubleshooting and some looking at some of the reporting part of it as well, and some of the out of the box reporting and custom reporting with some useful tips hopefully for you. So let's begin. So the slide that I'm showing first was one that you've probably seen before or very similar, listing, although it says deployment name on the slide, it really is similar to the pods. The pods are configured as deployments in Kubernetes. So a deployment is how they're controlled, how you would edit the configuration and things like that. So, and that's how they're listed here as a deployment. But each pod within it has various different containers running, and there's two stages of the pod starting up. There's the init stage, and I'll just get myself a laser pointer. The init stage for this one here at the top, for example, contains two containers, an install container and a dependence container. And then once the pod has completed those init container starts, so this is when you see, when you look at the Kubernetes pod status, you'll see that they're in an init stage first before they move into a running stage. So this is the init stage, and this is the two containers. So this is where you would see init 1 of 2 or 2 of 2. And this is those actual containers starting. That's what the output is actually showing you there in the Kubernetes output. And then once they've moved out of the init stage, they move into a running stage. And in this particular case of the AP bridge, you would see that there's another two containers. So in here you would have running is the status in Kubernetes, and the output would be a 1 of 2 or 2 of 2. So the first one that starts is the Kubernetes Vault Renew, which is in every single pod has a Kubernetes Vault Renew, and basically that starts first and connects to the vault to renew the tokens, which are basically certificates, which are going to be used for the intercommunication for this particular container. And then finally it will run the one that's obviously that's going to actually do the work, the one that you're actually interested in, which in this case would be the BVD AP bridge. So that's how the containers actually start, and how actually the pods start. And like I said, they're all controlled by deployments. So although you can delete a pod and the pod will automatically restart, if you wanted to stop that pod from running or have more than one pod running, then you would edit the deployment, and that's how that's basically how it works when it comes to BVD. The ones that are of interest for us when we're talking about using BVD for COSO, the first one, which has already probably been mentioned, is the BVD controller. The reason that one's important is the first pod that starts in the BVD, or the first pod that needs to successfully start in BVD. And once that one starts on the initial install, it actually does this database creation. So you can see as part of the init, it does a database creation. It actually runs this database creation every time it starts. But of course, the second time it starts, it will find that, oh, there's already the database tables have already been created. So it doesn't actually do a lot, but it still runs every time the pod starts in part of the init stage. So, and this init stage is a lot more than the others. So it not only has an install and dependence like the other two, it also has some other additional containers that will do it part of the init. So the BVD controller is the one that starts first. So on a brand new install, and it would be the one that creates the tables in the BVD database. So if after a brand new install, the controller doesn't start, then it could potentially be a problem connecting to the database. And that would be the first place you would go and have a look at these particular logs. So each of these containers has its own logs. So there's a log for every single one of these. So when you actually run the Kubernetes log command, then you have to specify which container it is you're interested in. And so, you know, would it be the BVD controller, the Kubernetes Vault, database creation, and things like that. So I can show you a quick demo if I can find one my system here. And I'll just get another tab so we can look at Kubernetes. So, for example, if I do cube control get pods, and the namespace is OPSB Helm, and I pipe for BVD. You'll see the BVD pods here. You'll see the state that I was referring to. This is the status 2 of 2. So this is 2 running pods. The init phase is already finished. So now we're just in a running phase, and we've got 2 of 2 of all of the pods that are running. So if I wanted to look at the logs of one of these pods, the Kubernetes logs, and then I could pick one of the pods. So if I do the controller, for example, you'll see that when I run it, it comes with an error and says, well, you didn't tell me which container it was. And this is great. I love this error because it actually gives you a list of all the containers that you could have chosen. And of course, you need to choose one. So the running containers, like we showed before in the other slide, are BVD controller and Kubernetes Vault. And the init containers are dependents of Redis, dependents of IDM, install, and database creation. So I can go, it depends now which log I'm interested in. I could then say, well, okay, well, the log that I'm interested in, or the container that I'm interested in, is database creation. So I just say -C for the container, database creation, and then I can look at that particular log. And that's how you get around Kubernetes and see which logs are of interest. Now, I should point out at this stage that when it comes to troubleshooting BVD, yeah, you can do it with the Kubernetes way, using all the Kubernetes commands, and that's great. And you need to learn them, because if you go to, with a customer, that's typically what you're going to be doing. But when you're coming to learn the product yourself and play around with it, perhaps in your own lab environment, then I use a tool called K9S. K9S is a third-party tool, so it's a tool that we can't recommend to our customers because it's not written by ourselves, but we can't even really suggest it. But it's a tool that I use, and if customers are willing to use it at their own risk, then I would say that it's a good tool to use. And the reason it's a good tool to use is because it gives you a real-time display of exactly what's going on. So although there's not a lot changing on this screen at the moment, it is actually being refreshed continually. So anything that changes will be updated here. So if a pod was to die, then you would see it here. If I scroll to the end, you get the full list. So for example, if I was to go and delete a pod, you would see that it would turn red. So let's just go and delete this one, for example. So I can delete this log from here by pressing Control D. And I just press OK to delete it. And just as an example, you see now that you can see the pod is now gone into this init phase of 0 of 2. Now it's going in init 1 of 2, and now then it will go into init 2 of 2. You see that the pod changes color to show you that it's not in a running state, or a proper running state. And now you see it's in running. So now it's in 1 of 2. You now know it's doing a cube, or it's done the cube vault renew. And now it's waiting for this 2 of 2, which means it's starting the actual Artemis container within that pod now. So that's actually what's happening here. And also what's beautiful about this tool is that, as I said, it's all visualized and easy to move around without me having to learn lots of Kubernetes commands. If I've got a question about what are these commands, I can press the question mark button, and it comes up with the help. It shows me all of the options that are available for this particular screen. So it is a bit context sensitive, so it depends where you are, shows you whatever. So if I wanted to go and look at the logs again in here, I could just go and highlight the BVD controller. I can just press enter, and it actually gives me a list of all of the containers within that pod. So that's great. So I don't have to now wonder which one it is I'm interested in. And then I can see here that these are the init ones, these 4 that are here, which have obviously run, and then they've completed and they've finished. That's why they show as a completed state. They ran, they finished, so they've done their job. And these are the ones that are actually currently running now, the other 2 blue ones. So this is also good. So if I wanted to look in the logs of the BVD controller this time, I can just press L to look at the logs, and you might get a screen like this that says that, well, there's nothing, it's completely empty. And it's because it's just showing the last 1 minute. So I have to use these options up here to select, well, I want to select all. So let's go and press 0, and I get all the logs now, which is great. So I can see all the logs now. And then I could say, well, this is a bit annoying because I want to, you know, some of this information goes off the line and I can't see it properly. So I can switch the wrap on by just pressing W, and then the word wrap goes on. And then I can put the timestamps on by just pressing T, the timestamps. So I get to see now exactly what's happening, because, you know, some of these logs occasionally, like up here, don't have a timestamp next to them. Some of them do, so it is actually useful to be able to pop in here and just look at the timestamps. So yeah, the Kubernetes is great, and using the K9S just makes it slightly easier to quickly move around. It speeds things up, but of course you still need to know what's happening behind the background, because otherwise you wouldn't know there's a logs and you wouldn't know that all these other features exist. So let's move on. The thing that you might see then when it comes to troubleshooting is the pods not being ready. So they might have failed in an init phase, or they may have failed in a running phase, and then you need to go ahead and check to see what's actually happening. So there's a couple of things you can do here to have a look at this. The first one is look at the events from the pod. So if we go back, and we can go here, and I'll actually go and do this from here. If we do cube control and we'll say describe pod, and we'll look at the controller pod, for example, and then namespace OPSB helm. Oh, no, it's just describe, I think. Yeah, and then I'll have to put minus container BVD. Oh, no, it's describe. But that's why. Things. So if I describe the pod, I don't know why my mouse has this annoying thing next to it. If I describe the pod, then at the bottom of it here, you'll have some events, and you see at the moment there's none. So ignore the errors at the bottom. That's because I got the wrong command line. But you see here, there's no events at the moment. But if there was a problem with this particular pod starting, then I would get some events in here, and they might show me what the problem is. So the first thing you do is, if you've got a problem with a pod starting, is to run the describe. The describe will show you some events at the bottom, typically showing you what's wrong with the pod. The describe output is, you know, it does look a bit heavy when you first look at it, saying, well, there's a lot of information here to try and understand, and what do I really need to know? And basically, it's bits of starting from the beginning. If you come from the beginning and look your way down, it will show you obviously huge amounts of information. The status of the pod is running. It will show you a little bit later down the init containers. So these are these 4 init containers that we saw before. So the first one is called dependence redis, dependence IDM. Then you've got the database creation pod. And eventually, when you've gone through all of the init containers, you'll eventually come down to the running containers, which is BVD controller. So this is the one that you're typically interested in. In here, it will tell you what the image is. So in here, I can see that my image version is 11.05008. So that's a one good way of finding what version of BVD is installed. Maybe there's a patch installed, and you want to go and check what version of BVD should be installed. And it gives you other information that's probably not so important for you to know at the moment. But one of the things it does discuss down here is this thing called a liveness check. And there's 2 checks. There's a liveness check and a readiness check. So a liveness check is a Kubernetes check, by the way. They're both Kubernetes checks. A liveness check is a check to make sure that the pod is alive, or in this case, the container is alive. But it's still used to control the actual pod itself, really. If the liveness check fails, then Kubernetes says, well, there's something wrong here, and it will and it may restart the pod for you automatically and says, well, it wasn't alive, so I've restarted the pod for you automatically. The liveness check in this case is done by internally inside the pod. So inside the BVD controller pod, what's going to happen is Kubernetes will get inside that pod and it will run this command, basically a curl command, or HTTP GET against this particular URL. And you might say, well, that URL looks a bit odd. It just has HTTP s :// and it should have a host name in here before the port number, but of course it doesn't. And it's a bit weird. I don't know why they do this, but it's basically assuming here that localhost is the output. So basically, if we were to drop inside the pod and we were to run a get against this, we would hope to get a success. The status code should come back saying it was successful. And then that would tell Kubernetes that this pod is alive. Now, you don't have to, the developer, in fact, who's responsible for creating this liveness check, has decided that's the way he wants to do it with this particular pod. He could do a shell script. He could do many, many different ways of checking to see if this pod is alive. It's completely up to the developer to choose, but this is the way that you could check. So if your liveness check kept failing, for example, maybe at the bottom of the event, you had loads of errors saying liveness check failed, at least you know you could log inside this controller container and you could run this command. So we could probably do this. So if I go here, do it in here. If I want to shell inside a container, see how quick it is with K9S. I just press S to shell in, and I'm shelled in now. And hopefully a curl is installed in here and get away with it's annoying with the mouse. Of course, I have to put localhost in here, otherwise that won't work. And it will fail because of it won't be able to validate the certificate. So I should be able to do. I think it's yeah, and you see that difficult to see, but you see I got an OK come back there from doing my liveness check. Came back with an OK. So if I go back over here, I could say, well, okay, my liveness check came back with a successful. It was quite quick, instantaneous, really. So, so my liveness check would be successful in this particular case. There's another thing called a readiness check, which we don't have in this particular pod because it's not mandatory. It's optional, again, designed by the developer. And again, it can look at, it can run a script, or it can connect to a URL. There's many different ways that a readiness check can be done. The difference between a liveness check and a readiness check is a liveness check checks to see the pod is alive, whereas the readiness pod checks to see if the application running underneath or inside that container is ready to receive network traffic. So if Kubernetes doesn't have a successful readiness check, then it will not deliver any network traffic to that pod. And then you'll get some weird error message saying in the browser when you try to connect to this URL, saying that there's a problem connecting to Nginx, or Nginx has a problem connecting, and you'll just get a weird error message saying Nginx from Nginx saying there's a problem. And then probably that it's down to some sort of readiness check failing, or the pod not running, or something like that. So if we were to come out of here, just do Control-C, exit from there, and let's go and look at the www pod, for example, and do a describe of that pod. And let's go and find the container BVD www, which is this one. You see, it looks just like the controller one. It's got a liveness check, but because this pod actually receives network traffic, www being the if I look at the container name here, BVD, it's the World Wide Web, so it's the HTTP front end for BVD. So when you log into BVD and you get displayed that that UI that you've been using for the labs, on Tuesday, that UI that you've been using there all comes from BVD www. It's the one that's hosting all of that. So it's the one that receives all that network traffic every time you click on a mouse button, or and do anything you do. It's all coming inside this one here. And Kubernetes is monitoring this to make sure it's ready all the time. And this is the check it's doing. It's slightly different to the alive check. It has a different check called ready. So That's what Kubernetes is doing in the background. It's checking to see if this pod is ready, and if it is, then it will deliver network traffic here. If it won't, then you'll receive that, like I said, that horrible Nginx error message. So that's what we show in the slide. We show that you're doing a describe of the pod. In the case of BVD www, there's a readiness check. And at the bottom of the describe, there's always these events. And in the case of a readiness failure, this is the type of error message you would get to see. And as I explained, you could shell inside the pod. So the commands here, exactly how you would do that if you weren't using K9S. And then you would do the curl. The -k is insecure, or you can do -- insecure. And it will show you the output. Obviously, the OK being the good, and you might get a different type of error if it's not ready. If you've got any questions, by the way, along the way, please don't hesitate asking. I can stop and answer any questions you wish. So we've looked at some of the containers. We've looked at how you would look at the events. We've looked at how you would look at the logs. We've looked at how you would check their status. But with BVD, for example, and what you've been doing this week is, the question is, well, how do I, and the big question that always pops up is, how do I design one of these dashboards? Because I might not understand the database fully to understand what it is I want to, what it is possible. And I think the hardest thing with this is you first need to try to have a slight understanding of the source of the data, to try that, and then you'd have an idea of what it is possible. So, for example, if you've got any background experience with BPM, for example, you would know that BPM is used to, or can be used to check a connection to a web browser, for example, or a web server, and have various transactions. So you could record the fact that you've connected to a web server and that you've logged in and that you've clicked on a particular button and some text should appear. And you would monitor that via BPM and set up some transactions, which would record how long that took. So it would tell you that, it took, 500 milliseconds to log in, and then another, 200 milliseconds to display the page. And you could have a look at that with some transactions in BPM. So you have an understanding of how the application works. And if you've used APM and looked at the reports in APM, you'd have a good understanding then that, that information is collected as response times. So you then would have some perhaps hope of having some understanding that's in the database. Hopefully there would be an application name of the BPM that server that you've connected to, and the application you're monitoring, and plus it should have some sort of transaction time. So that's what you'd have that in your mind, and then from that you could then have to look in the database tables and see if you could find that type of information. Unfortunately, there's no real documentation to say that what's possible, or what's what reports are possible from the data that we collect. And it's the same with the agent. If you've used the agent for any time, you would know that we have a set of golden metrics, as they're called, which go and collect a whole bunch of performance data. So they collect information on CPU, on disks, on network devices, on memory, and things like that. So you would know that the agent is collecting every 5 minutes CPU information, or swap space information, or something along those lines. So you again would hope that that information would be in Optic or COSO in the database there. So therefore you could, in your mind at least, think that it's possible to generate a report showing CPU over time, or swap space used over time, or network throughput over time, because that stuff is typically collected by an agent. So you need to understand the data source, is what I'm saying, before you can design your own dashboards. Now, once you understand your data source, what it is you're thinking of, then you can come to this URL here, and it lists all of the different sources of information that we support at this current time, which is system infrastructure, events, RUM, and BPM. And then, from there, you can say, well, okay, I'm interested in BPM, or I'm interested in operations agent, and you click on the relevant link. It would take you, in the case of operations agent, under system infrastructure, to these tables, which show you all the raw tables, the hourly tables, the daily tables, and the forecast tables that are available. And then you could really go and have a look on by clicking on any one of these links to see the actual data that is collected by default. So in here we could see that there's various different columns with different values and a description explaining what's stored in each in particular column. So from that information, you've decided you want to generate something about agents. You've decided that it's going to be either the raw data, hourly or aggregated tables that you're interested in. So for example, you'd pick the raw tables if perhaps you wanted to show information, over the last very, very granular information over the last every 5 minutes, for example. If you wanted to say, well, I wanted to show information over the last few months, you might choose hourly versus raw, because raw is going to give you lots of data points, whereas hourly is going to give you a more aggregated, averaged data over the, logged every hour. Or even in the case of a month, you might choose daily. And they've got different data in each of the tables. Some of this table has been calculated to be the average over this 1 hour, where this information would be more granular at every 5 minutes. So you've got to decide how you would like your, to view your data. And using this online information, which is customer visible online information, you could then go and decide what it is you want to look at. And then decide how to build your dashboard. So unfortunately, there's no easy answer to building your dashboard. You actually have to do some legwork to work out what it is you want to achieve. But like I said at the beginning, the first thing you have to do is understand what it is available from each of these areas. Now, how do you then go ahead and say, well, okay, I've decided I want to go and get some information, let's just say for the agent CPU, for example. I think you probably may have already seen this in Ankit's presentations. But basically, you'd have to, use a third-party tool really to access a database, because to try and do it in BVD is going to be very difficult, because BVD doesn't report back nice errors or give you the ability to browse through the tables. So using a third-party tool, you could use dbeaver, or in this case, we're using DB Visualizer, and you would connect to Vertica and to the ITOM DB port 5433. In this case, I'm using the DB admin, but you could use the read-only user if you wished. It's entirely up to you. And then you could log in and either browse the tables and look at the data, or you could run some commands to go and get data out of the database. The beautiful thing about doing it this way is if you make a mistake, then you get a nice error message back. And although the error messages sometimes can be hard to understand, at least you get an error message back, and you can at least Google it. Say what does table make? What's this says table? I think it says table name does not exist. In fact, it says table name X. I think does not exist. You see it here. The table is not called. It should be called table name, and in fact I've called it table name X, and that's given me the error message saying that the value doesn't exist. So yeah, it gives you a nice error message back, which is a lot easier to understand when you're writing your queries, because effectively that's what BVD is going to be doing. I did forget to mention, and I'll just pop back unfortunately, that all the queries that are run whenever you go into BVD, so whenever you've been writing in the lab, you went in and you created a dashboard and you created your data collectors. The data collectors were basically SQL queries into Vertica. The person that's responsible, or the component that's responsible for doing that, is BVD QueckServe. So QueckServe is like a query, to a server, if that's the way you want to think about it. It queries the Vertica server with the SQL commands that you've written inside the data collector. So that's the way in which this pod works, and it's responsible for doing all of those queries. So because I forgot to mention that what all these pods do in the case of COSO, I think I got a little bit distracted. So yeah, like I said, BVD WW is responsible for the UI. The QueckServe is responsible for all of the SQL queries into Vertica, and the controller is the one that's responsible for displaying all of the sorry, for creating all of the databases when it starts for the first time. So they're the only ones that are of real interest, really, I would say, when it comes to BVD with respects to COSO. So I've then provided some sample queries. I mean, I mean, if you've got any familiarity with SQL, then these are very, very simple indeed. But, you know, the fact that you can count stuff using the count, the fact that you can look for stuff using the where clause, and then you can say like, and then you can use wildcards. So for example, I'm looking here in the agent node table. So I'm looking at all the agent nodes. I'm looking for a node fully qualified domain name that has the word ver somewhere in it. So in the middle of it. It can be at the beginning, it can be at the end, but it can also be in the middle. So the percent characters act as wildcards. So simple. Oh, sorry, wrong. The other ones that are quite useful are the max, and there's also a min as well. I haven't shown the min, but you can say, show me the max timestamp in a particular table. So this is really useful. So in this case, I'm looking at OPR events, and I'm saying, show me the max timestamp. This shows me the last time an event was received into the Vertica OPR events table. So this should effectively match the last time an event came into OBM if you're forwarding all events. So, you know, when you forward events to Optic, you can decide with the forwarding rule what you forward. And typically we forward, in the examples, we forward everything. So all events. So in that particular case, if a new event comes into OBM within a few seconds, that event should also be available inside Vertica in this particular table. And if I want to check when was the last time an event arrived, this was to be the command that I could use. And I could say, well, if I wanted to look at the range of events, I could use the min in here and say, what was the last time the first event ever was recorded in Vertica? And that would give me the min time, which is also useful. I mean, in case of you're looking at retention, so you might want to look at how much data is in this particular table and when is the retention being looked after properly. So you could look at the min and the max, and then you would get an idea of how much data exists in this table between a time period, for example. So if in BVD, for example, if you were to go in there and say, well, I wanted to look at data over the last year, but the data only runs up in the dashboard up until March, and I was expecting it to go all the way back till January. Why isn't that data there? Well, you could use the min and the max in that particular table, and you could be able to see how much, you know, what was the first time data was ever logged there. The timestamps in a lot of the tables, not all of them, but a lot of the tables are in this UTC epoch time. So, and you know, and that's not human readable unless you're some type of supercomputer, and maybe you are, but I certainly am not. So when I look at the epoch time, I can't always work out what the exact timestamp is for human readable format. So there's a nice function here called toTimestamp, which will convert your epoch time to a nice human readable timestamp. I like that a lot. The other thing you can do is I could have used the min and the max in my example, but I could also use something here where I could say, show me events between a particular time from. So where the time stamp is greater than the 24th of March at midnight and until the end of that, end of the 24th, and just show me how many events are there and actually list them. Or I could do a count. I mean, whatever I wished. But yeah, that's the type of thing that I could do here quite easily with these queries. In comparison, if I write these queries in BVD and I make any type of mistake, so if I misspell anything, if I forget to include a space or a comma or any syntax typo whatsoever, all I get to see in BVD is failed to get sampled data, query is invalid. So it's not going to tell me that, well, the table name is wrong, or there's a typo, or you know, there's a syntax error, or I don't understand what this particular function is that you're trying to execute does. You're not going to see any of that. All you're ever going to see is this red bar, and it doesn't give you any help at all. So it can be very, very painful. So that's why you basically have to use a third-party database tool to do your to develop your queries. And once your queries are ready, then you can just copy and paste them in here, remembering to drop the final semicolon that you would use in a normal Vertica query. And because in BVD it doesn't accept the final semicolon. I don't know why, but it doesn't. I think that's one of the only other error messages it gives you is it tells you that there's a semicolon included and you don't need it. But that's about it. So that's how you would develop your queries. You could have in the query some sort of clever calendar function, like you see here. I've got a calendar function. So basically what's saying here is I'm going to get a calendar on the left-hand side of BVD that is going to pop out that you've already used, and I'm going to select the last, 7 days or a particular timestamp, and that's coming from the calendar function. So you could say then, okay, that's I can't really do that in BVD maybe, but you actually can, and you can actually use a calendar function in BVD. So if I was to copy this into a calendar function in Vertica, so this calendar function here with a start and end time, you might say, well, I can't copy and paste that query into DB Visualizer and run it there. Well, you actually can, and DB Visualizer will pop up a calendar and ask you to manually enter the time. It doesn't actually come up with a UI. It just comes up with a free-form field where you actually have to enter the start time and the end time or whatever it is you've configured here. So it does take some functions, but not all. So some things like time zone, for example, may be specific to BVD and therefore they may not work. So some stuff you might not be able to run. And that in that case, if you've got a problem where that's not actually working, then you can start looking at the actual query that gets created from this. So obviously, the query that's sent to Vertica doesn't say calendar start time and with the timestamp. It's actually replaced with the start time that you select in the calendar. So and you can't actually see what's actually sent to Vertica. You just get this error message here. So there are certain situations where you can't run the whole complete query in your third-party database tool, and you might need to run it in here. And then you want to see what that query looks like. And in that case, you'd have to enable debug for this QueckServe, and we'll come to look at that in a minute and how you'd actually do that. So yeah, that's how you would troubleshoot the queries in BVD if they don't work there, but maybe they work in your database tool, but they fail to work when they come inside BVD. So the next thing, let's have a look at report troubleshooting next. So we've got a report. This is one of the out-of-the-box reports, events by policy. And when we've, and maybe the problem is that when they've clicked on, the customer or yourself has clicked on this events by policy report, that there's nothing displayed in this part of the report, and you want to know why. So the first thing you would do is edit the dashboard, click on the widget that you're interested in, and then you would get all the properties across the right hand side here, and it would show you the data channel that you're actually is actually being used by this widget. So that's the first thing you need to do. Once you found the data channel, then you can go to the data collectors. You can filter them out by the name just to make it easier for you, and then you go and find this policy summary trend, which is here, policy summary trend. And then you can go and have a look at the actual query and run it and see if it actually returns back data. So that's how you would sort of troubleshoot to find out why there's no data available in your particular widget. The naming of these data channels for the out-of-the-box stuff is all done very thoughtfully. So they all start with OPSB, and then there'll be some sort of type of content, in this case event, and then there'll be some sort of reference to the report. So this is a policy report. So this would be a policy summary. And then there'll be some sort of query about what does this query actually do, and it does some sort of trending. So yeah, you can see here that they've tried to be very, very thoughtful with the names. Although they don't roll off your tongue, you can't just look at this and say, oh, I know what that would be. You tend to have to go and look and find it, but they do actually make sense, well, to me at least. So once you've configured all these data channels, or the ones that are out of the box, if one was missing, for example, there is a way of checking what data channels are available. So the data channels are these channels that appear here. And I could run this this REST call, and it will give me a list here in JSON output of all of the data channels that have been created. So if you're missing a data channel, you've created a data collector, but you don't actually see it, it's not available in this list here, then you could look at this JSON and see if it appears in this list here. But effectively that's what that's doing in the background anyway. But this is just a shortcut to show you how you get there. And the next part, well, this part's a slightly more
Colin,
complicated.
one query.
Yes.
Abhishek, yeah, there's a query. So in the previous slide where you were talking about the SQL that we type and we create the data channel OPSB event whatever, and then you have a widget to match, and that widget looks like a time series kind of a thing, right?
Yes.
Now the output of this the data channel or the SQL behind that will give us, say, a table of 4 columns, right? Just a wild guess. So that 4 columns become each of the variable in the data channel, right? 4 variables will show up.
Yes, effectively, yeah. If I think about that correctly, yes, effectively,
Yeah,
you would see that. Yeah.
yeah, because we did the exercise and that's how it came. The question that I wanted to ask was, because for suppose this is a time series widget and the output that is coming is say 20 records, and I think the time will automatically come at the x-axis for this. So my query was that if the output is, say, having 1,000 records, right, and the widget that you're having is a time series which will match the table and I mean the chart thing, how long will it track back the output in terms of the data points, the 1,000 record kind of thing?
Yeah, I mean, if it was that is one of the issues that you do have. I mean, that's where you have to be sort of quite thoughtful about how you're going to do this. If you're going to have a calendar widget and you're going to go back 9 months and you're looking at the raw table, then yeah, it will try and pull all of the data channels, all of the time points for the 9 months every, let's just say every 5 minutes. So BVD does do a thing where it looks at the query that you're running, looks at how much data is coming back, and it does try to do a sampling of that data to smooth. So basically, instead of returning back, say you've got 9 months worth of data every 5 minutes as your time series, BVD when it runs that, and it actually does some sampling of that data when it comes back, and then it will try to not show you every single data point. I haven't seen it work particularly well though when I've done it, when I was playing around with these with the labs that you've been using. It doesn't always work in the way which you would hope it would work. So you can sometimes get a time series graph with actually literally thousands of points, and it takes quite a long time, and sometimes it can cause your dashboard display not to actually load because there's too much data returned. So sometimes you do have to be a little bit careful on what you're going to do. So if you're planning on your dashboard widget to be used for, and you're giving it a calendar function, you might not want to use the raw table if there's going to be 3 years worth of data, for example, because that could be a bad idea. You sort of might want to sort of say, well, I'm going to limit this to being selected by using the hourly data. So therefore, I've got less data points, or I might use the daily one, so I've got less data points. And you saw that in one of the labs where I'd used raw, hourly, and data, and you could see how the different data points appeared. So yeah, you do have to be careful. And back to your question, yeah, one of the tips that will come at the end of this is you have to include in your data the value ID or timestamp in your query. So when your query runs, it should always have an ID displayed or a timestamp. You see down here in this example, we've got timestamp shown as timestamp. The reason we don't leave it as timestamp TZ is because when BVD receives the data, it's looking for a field called timestamp.
Okay,
it uses
that's how it matches the x-axis.
Yes, that's how it matches it. Or the file, or it can be called ID. It doesn't matter which. Either one will work. But yeah, that's exactly how it works. Yeah. So and that's one of the.
Sorry, please go ahead.
No, you go ahead. Sorry.
Yeah, so I mean, I got your point that it will do the sampling in a widget in this line chart type of widget. What about the tabular widgets in which we expect the tabular output? Will it do the pagination or accordingly for all the 10,000 records or whatever?
Yeah, I've not played with tables, to be honest, so I'm not too sure exactly how, when you put the data into the table, how it will deal with data that runs beyond. I seem to think that there was, yeah, I can't remember now exactly off the top of my head, but I do remember seeing an example of tables where the table data outruns the size of the table and how it deals with it. But I can't remember exactly how it works. But no, I've not played with the tables. Sorry to have more information about that, I'm afraid. Yeah. Yeah, my exposure to is somewhat limited, I guess, in certain areas when especially with the tables. I've not played with that.
Okay.
So yeah, let me discuss the troubleshooting of reporting, which you may have seen a little bit already, but let me just show you it from my perspective when it comes to BVD. So let's just say you've got an event report. So you've gone to the out-of-the-box reports, looked at events, and you want to look at one of those reports. And so you need to go to the widget, and you need to have a look at where's the data coming from. Is it coming from the raw table? Is it coming from the 1 hour table, or is it coming from the 1D table? And you need to, that's the first thing you need to do. Which table is my widget pulling the data from? So once I've decided that, I then could say, well, if it's coming from the raw table, that table is populated by data from OBM directly. So there's no input really at that point from Vertica, and in Optic are not really doing any manipulation of the data there. The data comes into the receiver and then it's placed inside the raw table. That's it. So if I'm getting data out of the raw table, I've got not a lot really involved. If the data's in the raw table, it should appear in the BVD, it should appear in the dashboard, in the BVD dashboard. If the data doesn't come into the raw table, then there's a problem with the data coming from OBM, or there's a problem with the data coming into the receiver and being placed in the raw table. In the case of the 1 hour and 1 day tables, though, that's slightly different because that data is manipulated by us. So we read the data out of the raw table and we place it into the summary hourly and daily tables using some things called task flows. These task flows all are named in respect of the sort of data that they're dealing with. And they're responsible for being executed some of them run every few minutes, some hourly, some daily, depending on what the task flow is responsible for doing. And it's responsible for putting that data into these tables, manipulating the data in some ways and putting it in those data. So maybe working out an average or whatever it needs to do with it and putting that data into those tables. So basically, if these tables don't contain data, but the raw tables do, then there's something happened. Something's gone wrong with the task flow. And that's what you would then need to troubleshoot. Now, if I just go back to my system, and I know I'm taking time discussing what we've discussed so far. The task flows. To look at the task flows, there's two ways. There's a lovely support tool that one of my colleagues wrote, Chris Stone, which is brilliant. And this will list all of the task flows. Maybe it's a bit overwhelming for people that are not familiar with task flows, but it lists all of the different task flows and tells you if some of them are running. I have to run this. It's not updated automatically. I ran it this morning before we started. But yes, it will tell me if they're running, if they finished, if they were a success, and if there was any type of problems. Success with warning basically means that eventually it was successful. There was some warning along the way, but it still was able to complete, which is the good thing. And it tells you what time it started and what time it ended. So if we imagine today's date, and funny enough, it's the 29th of April today. What's quite weird is in my report here, I've got some task flows were started on the 29th and finished successfully, but I've got some which started on the 21st and have never finished, and some that started on the 20th and have never finished, and some also that started on the 26th. Oh, sorry, they have finished, but some of them started on the 26th, finished on the 26th, but they haven't run again. You know, what I'm trying to say here is the output should always really be the 29th. You know, it's or at least the 28th, depending if you've crossed over the midnight threshold. But I should be seeing these should be updated basically every day, at least, because the longest ones are daily. So sometimes you can see in here they say hourly here, and some of them say daily, 1D being daily, 1 hour being hourly, and some of them have actually got it in writing up here, hourly and daily. So my hourly and daily should at least contain, should at least be running every hour or every day. So if I see the one from the 26th, and although it finished on the 26th successfully, it should have actually been executed on the 27th, 28th, 29th, if it was daily. And if it was hourly, it should have been executed hourly. And you see that they're not being updated here. So this shows me that there's a bit of a problem here. You can see that in this particular example, the 26, 26, 26, 26, they're all 26, but this one actually started on the 29th. So you say, well, that one actually ran on the 29th and finished on the 29th, but these ones above it didn't. What you then need to do is look at the task flow name. The task flows are all executed together. So all these ones here that say sys CPU, so if I try and do that with a better highlighting like that, they'll all get executed as one task flow, but as individual tasks within that task flow. So this task flow called CPU will have executed each one of these when the task flow runs. And you can see that they were all successful on the 29th. So that's good. That means that that one ran. So I shouldn't have any problems with my sysinfra CPU tables because they were all successful. But if I look at this particular task flow, the top one up here, sys availability, I can see that none of those ran on the 29th, and they should have. So there's something wrong with my task flows. This means that the data in my reports is going to be out of date. The latest data in my reports is going to show the 26th because it never executed ever again afterwards. And the same down here in this netif one down here, it only ran on the 21st. So I'm never going to see any data in my aggregated tables that's beyond the 21st for anything to do with networking. So these are agent networking, agentless networking, or anything like that is not going to have executed. The reason why, well, then that's where the difficulty comes, and I need to sort of troubleshoot that. So let's go back to the slides. So yeah, so basically what would happen there is if I've got a problem with one of these where those task flows are not executed and they haven't finished, it could have been because they failed, and you'll see one of these failed non-recoverable or dispatched states, but I didn't see that in my particular case. But in your case, if you did see that, then there's some troubleshooting docs, and we'll have that at the end of this presentation, where you can actually tells you how to go and try to resolve those types of problems. My problem is a lot more complicated in the fact that they're not run at all, and therefore I've got to follow a different troubleshooting path, again, which is documented. So yeah, that's what happens with the task flows. There's also logs. So I could actually go and have a look at the logs and troubleshoot this a little bit deeper. So first of all, I would need to understand, you know, a little bit more to try and find the logs. So in this particular case, I would, and it's very difficult, and it's to find. It's not easy at all. First of all, I'd have to find out which is the logging volume. I don't know if anyone has showed you, but this is even that is difficult. So to find the logging volume, you know, you sort of really do have to start running some commands. So I'd have to do a kube control and get PV for namespace OPSB Helm, and then I'd have to go and look in here for the OPSB Helm log volume. And you see over log volume over here is this one, and then I'd have to go over here and say, well, that one's actually called OPSB vol 5. So on my NFS server, wherever I created my OPSB vol 5 folder, that's where all the logs are going to be. So that's the first thing I need to do is find out where's my logging volume, and that's this bit here. So my logs, and then would be that part. So in here, var vols NFS OPSB vol 5 in my particular case. Then your namespace, so OPSB Helm or whatever you've decided to call it. And then the location that you want to go. Now there's when the task flows are run, they're actually run by the task executor pod. You'll have seen that there's a pod called task executor, and it's responsible for running all of these task flows. So that's where you would need to go. You need to go to the current one. So you would need to go and find what is the current pod name. Again, Kubernetes would help here. So in Kubernetes I can grep and look for task executor. So this is my current pod name. I'd have to get that pod name, and then I could then go back here and say, well, okay, that's my pod name. I can put that in my and find that particular directory. And then once you go to that directory, you will find various logs, including the aggregate log and various others. And then you can have a look in those logs to see what actually went wrong. So that's the way in which you would actually troubleshoot a problem with the events. And it's the same for all others. So in this case, we're looking at sysinfra. It's exactly the same. There's no difference. The task flows are the same, different names, but it's the same procedure. We have a task flow for system availability. We would also look to see if they're in a particular failed state. If they are, follow the troubleshooting. If they're not, then go and have a look at the logs. Of course, if it's raw, then you don't need to worry. It's, you need to look at somewhere else. You don't need to be looking at the task executor logs if you're looking at a raw table, because the raw table is populated by the agent metric collector or metric streaming in this particular case, or from Sitescope, the raw tables. But in the case of an aggregate table, hourly or daily, then you need to look at the task flow and the task flow logs. So some examples here of some of the things you might see in task executor logs. These are very, very simple examples, basically showing that we were unable to connect to the Vertica database. So that's the simple example there. The troubleshooting docs that I referred to can be found here, and this is great. So I can come to this lovely task flow and troubleshooting page, and there's a whole bunch of, and I haven't copied them all here, the list is long and growing, of ways to troubleshoot what's going on. So first of all, I need to sort of have a basic understanding of what my problem is, and then I could try and find it in this troubleshooting report, and then follow the steps. And the steps usually have a remediation part to them. So they have a problem description, a checking area, and then some sort of way of actually fixing this particular problem. And the ones that I've used have worked, so they tend to work. So how do I look at the task flows if I didn't have that lovely support tool? Well, in this case, we would use the ITOM DI monitoring URL that's part of the install. When you installed Kubernetes and OPSB Helm Suite, you will have it will have automatically created this URL here called ITOM DI monitoring, which brings you to another web interface where you can actually log in using the DI admin user that you created inside your values.yaml. And you could log in here, and it would basically use the manage button, dashboards manage. And then underneath COSO, you would see various different dashboards that you could view. We're interested in task flows, and you see there's a nice little area on the right side over here that shows you what this particular dashboard called post load details actually contains. It contains stuff about task flows. So I could then go here and I could look at the task flows just like I showed you in my output. The difference being here, I have to select the task flow name from the top. So I have to select which one I'm interested in, and then it will show me some sort of history of the tasks that happened in the same way that I showed you the output before. Exactly the same. You've got the task flow names, you've got the start time, the end time, exactly success and finished, failed. You would see in that output, which is great. Yes, so that's the way you would do it if you didn't have access to that tool that I just showed you. So some of the tips and tricks that we wanted to quickly show were that, as we already mentioned, it was a great question that was asked before, that how does the time axis get identified by BVD? So like I said, you have to use a field called timestamp or ID. So otherwise, BVD will just show you a single point on the graph. So even though you may have 1,000 data points returned, BVD will just draw a single dot on your time series axis, and you'll wonder why. And it's probably because you don't have a timestamp or ID field returned in your query or named in your query. The other thing was, how do I look at these queries being executed by the QueckServe? Typically, if you went to the QueckServe log, you won't see anything at all. You will just see some error and audit information being logged there. And so you have to switch the QueckServe log into debug. And to do that, you would edit the deployment and you would switch on debug, and then you would look at the particular logs. I'll try and show you this dead quickly. So what we would do, and I'll show you this way because this is the fastest way of doing it, is first of all, I would want to go and edit the deployment for QueckServe. Now, at the moment, I'm looking at pods. So I've done a get pods. So what I want to here is look at deployments. So I look at deployments, and I find my quick serve deployment, which is here. I can edit it as a YAML file, and I can go and search for the word debug. I find debug down here. I have to remove everything. So I insert, I'm just going to leave a star. I save it, I write it, and then you'll watch this will now change to say it's been deleted. If I go back to pods, you'll see the Quex server's now been restarted automatically, taken into effect that now it's running in debug mode. So now you see QuickServe, the new QuickServe is running, the old one is still terminating. So now I can go and have a look at the logs. Again, I want to look at specific logs, so I'm going to go in and look at just those logs, and I want to look at all time with a timestamp. Okay, so now my logs are in debug, and what I could do is I could, sorry, if I can find my, buttons to press. I can just quickly go over to my system where BVD is running, which I believe is this one. And I could log in. And this has already run a query for me, but let's just go into the dashboard queries, into the data collectors, and I could go and find one of the data collectors that I'm interested in. And I'll look at the, it just takes a while to load. And I could go and have a look at what I wrote for this particular one. So we could go and look at total nodes, for example. I could edit that and I could run it, and it comes back, it's run successfully. Now, if I go back to my logs, you can see that now in here, I actually have some select statement here. So I have an execute query. So I've got select, and I can actually see my query being executed. And I can see it got one result. Again, I can see my query being executed and getting one result. So in here, I can actually see my queries actually being executed, and there's other ones up here. Because remember, when I first logged in, it also ran a query. It's not just from the database collectors; it's actually from the BVD dashboards themselves. So each time I run a query, I get to see that output in the debug. So that means I can copy and paste this query. If I switch the word wrap on, then I could go and get my query. So my select time. So my query is here. Select timestamp. And I could copy that query into DB Visualizer and execute it and see what's going on, just in case there's a mistake or there's some sort of error, and I want to understand what that error message is. So yeah, that's how I would debug what's going on with the Vertica queries inside of BVD. There's the command to get the logs in case you're not using K9S. So we're coming to the end now. So resources. I put some links here on how to find the documentation, how to troubleshoot BVD, and there's also other dashboards on that are available to be downloaded as samples on the marketplace, which you can then use to generate your own dashboards. And that's exactly how I did the one for the lab. I downloaded an example from here. I think it was something to do with AO banking or something like that. I downloaded it. I liked the look of it, and then I just modified it to suit my needs. Here's some of the other tools that are available in case you want to go a little bit further. And there's other support tools. So for example, there's a log grabber, which will go and collect all the information that you could provide to support. You can download the log grabber for the container. And it doesn't just deal with BVD, it deals with the whole of it. So COSO or Optic, BVD, OBM, everything. The log grabber will collect everything, or collect information just specific to the area of interest. It gives you the option. The task flow status output is what I ran before. and that's a tool written by support, so that's not publicly available at the moment, but we will probably put it into the troubleshooting toolkit at some point. And also another tool I wrote to find the logs quickly, which again will probably end up in the troubleshooting toolkit at some point as well, because it can be difficult to find the logs. So these are some of the tools that we're working on, which are not available in the toolkit at the moment, but will potentially come. And then finally, I just wanted to show you the lab exercises and to show you what you should have got from your lab exercises. I hope you were all successful. I hope you enjoyed the labs. And at that point, I've finished, and we can have a Q&A, and I can say thank you for listening to me witter on for the last hour. So thank you. Any questions, please feel free to ask. I shall try and answer them to my best ability. If there are no questions, then I can hand it back to Alexei.
All right. Thank you so much, Colin. It was
You're very welcome.
A great session. I think there was a lot for everybody to process. So definitely